In the early months of 1945, as the Third Reich was collapsing under simultaneous pressure from East and West, the German High Command was running a logistics operation that most historians have examined only in passing, and that, if it had succeeded, would have altered the final phase of the Pacific War in ways that are genuinely difficult to calculate. The operation was a series of supply runs between Germany and Japan, conducted by specially modified U-boats capable of the extraordinary range required to cross the Atlantic, transit the Indian Ocean, and reach Japanese ports without surfacing in waters controlled by Allied air power. The cargo these boats carried was not conventional military supplies. It was technology, precision instruments, specialized metals, industrial chemicals, and in one documented case, uranium oxide, the raw material for nuclear weapons research. Japan's war industry in 1944 and 1945 was being strangled by the same kind of submarine campaign that Germany had failed to maintain against Britain, and the materials these U-boats were carrying were intended to address specific industrial bottlenecks in Japanese weapons production that Japanese domestic industry could not resolve. If enough of those boats got through, the last year of the Pacific War would have been fought against a Japanese military that was materially better equipped than the one the Allies actually faced. No? U-Venturer's 86-4 was one of those boats. She departed Kiel in December 1944, carrying 62 tons of liquid mercury sealed in steel flasks, a cargo of aircraft engine components, and a passenger list that included German technical specialists and Japanese naval officers who were being repatriated after completing their assignments in Europe. The mercury was the most strategically significant element of her cargo. Mercury is an essential material in the production of certain fuses and detonating mechanisms, in the calibration of precision instruments, and in specific metallurgical processes used in aircraft manufacturing. Japan's access to mercury through its own domestic sources and its controlled territories was limited. 62 tons of it, delivered to a Japanese war industry that was being asked to produce the aircraft and weapons for the final defense of the home islands, represented a meaningful contribution to Japanese military capability in the period when American planners were projecting the casualties of a mainland invasion in the hundreds of thousands. She never arrived. On February 9, 1945, HMS Venturer, a British V-class submarine commanded by Lieutenant James Launders, found U-86-4 in the waters off western Norway and accomplished something that had never been done before and has never been documented since. She tracked a submerged submarine using passive sonar alone, constructed a firing solution from bearing data that contained no direct range or speed information, and sank her with the fourth of 4 torpedoes while both submarines remained submerged throughout the engagement. All 73 men aboard U-86-4 went to the bottom with her. The mercury sealed in its steel flasks went with them. It is still there 80 years later, corroding on the seabed off the Norwegian island of Fiji, leaking into the marine environment in quantities that have made the site an active environmental management concern for the Norwegian government. The torpedo that Launders fired in February 1945 solved an immediate tactical problem and created a very long-term environmental one. The story of the HMS Venturer versus U-864 engagement is typically told as a tactical story, the unprecedented submarine versus submarine kill, the mathematical achievement of the firing solution, the technical details of passive acoustic tracking applied to a moving submerged target. Those elements are real and they are significant, and they will be examined here. But the framing that treats the engagement purely as a tactical curiosity misses what the engagement actually prevented and what it tells us about the strategic logic of the final year of the Second World War. U-Venturer's mission was not a routine patrol. It was part of a supply chain that the German and Japanese governments had constructed to partially compensate for Japan's material disadvantages in the last phase of the war, and it was operating at a time when those disadvantages were becoming decisive. Understanding what was on U-86-4 and where it was going is the context that makes Launders' tactical achievement strategically significant rather than simply remarkable. The German-Japanese technology transfer program, conducted through submarine supply runs, designated as Yanagi missions, had been operating since 1942 with mixed results. Early boats had carried blueprints, technical specialists, and samples of German military technology, including radar systems, torpedo designs, and aircraft engine specifications. Japanese scientists who had been studying German technology in Europe returned on these boats with knowledge that influenced Japanese weapons development programs. German engineers who traveled to Japan assisted with specific manufacturing and design challenges that Japanese industry was encountering. The program was limited in scale by the distance involved. A round trip between Germany and Japan covered approximately 30,000 nautical miles, requiring specially modified submarines with vastly extended fuel capacity, and by the Allied anti-submarine capabilities that were destroying German submarines in the Atlantic at an accelerating rate. Of the boats that attempted the run in 1944 and 1945, a significant proportion never completed their missions. U-864's specific cargo was chosen to address identified gaps in Japanese weapons production capability. The mercury was the priority item. Aircraft instrument production requires mercury in significant quantities, and the precision fusing mechanisms for air-delivered weapons depend on it. Japanese aircraft production in 1944 and 1945 was being pushed to maximum output to generate the aircraft needed for the planned homeland defense, but instrument quality and fusing reliability were identified problems that affected combat effectiveness in ways that raw production numbers did not capture. 62 tons of mercury was not a symbolic gesture. It was a calculated industrial intervention. The aircraft engine components and technical specialists aboard were complementary. German expertise in specific manufacturing processes that Japanese factories were struggling to implement at the scale the defense plan required. Commander Ralph Reimar Wolfram, U-864's commanding officer, was an experienced U-boat commander, conducting a mission he understood was strategically important. He had departed Kiel, transited around the British Isles submerged for the most dangerous portions of the passage, and was in Norwegian waters to address a technical problem, the defective exhaust valve that was producing the noise that Launder's hydrophone operators would detect before attempting the passage south toward the Indian Ocean. The stop in Norwegian waters was a delay imposed by a mechanical fault, and it was the delay that killed her. In the waters where U-864 was operating, with a mechanical defect that made her acoustically detectable to passive sonar, she was vulnerable in a way she would not have been in the open ocean. Launder's detection of U-864 was the product of competent patrol technique combined with the specific acoustic signature that U-864's defective exhaust was producing. The sound was not large, a rhythmic noise that required the Venturer's hydrophone operators to be attentive and the tactical situation to be quiet enough for it to be discriminated from background ocean noise. But it was consistent and it was directional, and once Launder's operators had identified it as a probable submarine contact, the decision to remain submerged and attempt a covert approach rather than surfacing or using active sonar to confirm the contact was the decision that made the subsequent engagement possible. Active sonar pinging would have confirmed the contact's range and bearing precisely, but would also have alerted U-864 that she was being tracked. Launders chose to remain passive, accepting the limitation of having only bearing data to work with in order to preserve the element of surprise. The 3 hours that followed were a test of a mathematical approach that naval doctrine had not previously endorsed. Passive sonar tracking for the purpose of generating a torpedo-firing solution was not in the Royal Navy's published tactical doctrine in February 1945. The doctrine for submarine attack assumed a surfaced or periscope depth target that could be observed visually through the attack periscope, with range estimated by the statometer instrument built into the periscope optics. Against a fully submerged target, none of the doctrine's assumptions held. Launders was improvising, applying the mathematical principle that consistent bearing observations over time contain motion information, that the rate and pattern of bearing change encode course and speed data that can be extracted by a commander who plots carefully and reasons correctly from the bearing sequence. That the solution he developed was not precise. It was an inference, a most probable trajectory for U-864 based on the observed bearing pattern, with uncertainty ranges around the course, speed and depth estimates that he was making from acoustic data alone. The 4 torpedoes he fired were fired as a spread designed to cover that uncertainty, with different running depths to address the unknown depth variable and temporal spacing to address the uncertain speed. The first 3 torpedoes missed. Wolfram had heard them and maneuvered. The 4th torpedo hit, because Wolfram's evasion had taken UP-864 into the path of the last weapon in the spread, the weapon whose calculated intercept point accounted for a target maneuvering away from the first 3. Whether this was a feature of Launders's firing solution or a confluence of the geometry of UP-864's evasion and the spread pattern is a question the engagement's documentation does not definitively resolve. What it resolves is the outcome. The 4th torpedo hit. UP-864 sank. Her cargo went with her. The wreck was found in October 2003 by the Royal Norwegian Navy during a survey of the area. The discovery confirmed the engagement's outcome and provided a physical record of what had happened on the seabed that the operational reports from February 1945 could only estimate. The wreck is in 2 sections, consistent with structural failure at the point of torpedo impact and the subsequent collapse of the pressure hull. The mercury flasks are present in the wreckage. their condition deteriorating with each passing year of saltwater exposure. The Norwegian government has spent years assessing the environmental risk and evaluating remediation options, a process that is ongoing and that reflects the difficulty of balancing the environmental imperative to contain the mercury against the ethical obligation to treat the site as a war grave for 73 men. The strategic consequence of the engagement, the mercury, the engine components, the technical specialists, and the Japanese naval officers who were all on the seabed rather than in Japan, is not calculable with precision. History does not permit experiments with controlled variables. What can be said is that the supply chain U-864 was designed to address real material gaps in Japanese war production, that the specific cargo she was carrying had been selected to address specific identified problems, and that those problems remained unaddressed. Whether the mercury and the technical expertise aboard would have made a measurable difference to Japanese military capability in the final months of the war is a question that cannot be answered with certainty. What is certain is that the decision by Lieutenant Launders to remain submerged, to commit to a 3-hour passive tracking evolution that naval doctrine said should not work, and to fire a spread solution built on inferred rather than measured data produced an outcome that removed a strategically significant cargo from the war. The tactical achievement was unprecedented. The strategic consequence was that 62 tons of mercury and everything else aboard U-864 never reached Japan. They are still on the seabed off Fedje, Norway, 80 years later. The torpedo that put them there was fired by a 25-year-old British submarine commander, solving a problem that the textbooks said could not be solved. He did not have a textbook for what he did. He had a plot, a pencil, 3 hours of bearing data, and the tactical judgment to fire when the solution was as good as passive acoustics was going to make it.